All right, now we're recording. Oh, I love that picture on your profile there, Alexander.
Okay.
Yeah, if you would have just surrendered to the force, that'd be great. Nice. Okay, so the way we're going to do trivia is by using your chat option. Down at the bottom of your screen, you should have an option to open up a little chat box.
Yep.
Here over on the right. What you can do is you can type your answer as fast as you can into the chat.
What if we don't even know the answer?
You can just guess. You can totally just guess. There's no penalty for getting the wrong answer. And so you could just make like a really fun answer if you don't know the correct answer. That's totally fine too. All right, so here is the first trivia question.
Okay.
Ready?
Yeah.
How many planets are there in the solar system? Got 2 answers in. Anybody else? 3 answers in. Who else wants to put their answer in there? 4 answers in. There's a 5th answer. All right, so many correct answers as well. Everybody who said 8 is correct. And we used to have a different number of planets, right? We used to have 9 planets, but poor Pluto got kicked out of the planet club. All right, so let's do one more trivia question, another planets trivia question. How many planets have people walked on? How many planets have people walked on? It's a bit of a trick question, by the way. How many planets have people walked on? Got a couple answers in.
Wait, I have a question.
Yeah, what's your question?
Is the moon a planet?
Oh, great question. It's not a planet, it's a moon. That was the tricky part of that question, huh?
Because we walked on the moon, but it's not necessarily a planet.
We have walked on the moon. All right, we got a lot of answers in now. Yeah, everyone who said 1 is right. The only planet we've walked on is Earth.
Earth.
Yep.
Hasn't Mars been walked on? No.
Not yet.
Has only rovers been on Mars?
You're right, just rovers. Yeah, and we've also had rovers on Venus and on Mercury.
Who's Howie?
Howie's my brother.
Oh.
Okay, let's do one more trivia question, and then you guys can ask me all the questions that you have about space. So let's see. Next trivia question, we'll keep to some planet questions. Let's see. How many rocky planets are there in the solar system? Planets that have surfaces that we could stand on. How many rocky planets are there? Planets that we could actually land a spaceship on and walk around. We got 1 answer in. Who else wants to try?
2, 3, no?
You got 2 answers in, 3 answers in, 4 answers in. Who else want to try? All right, bunch of answers in. The correct answer is 4. But yeah, who thinks they know all 4? All right, go for it, Alex.
Oh no, I thought Venus, Mercury, Earth, and Mars.
Yeah, man, you got it. Nice work. I think a bunch of you knew that too. All right. So now we've kind of like got started with some planet trivia. What other questions do you guys have? And it could be about planets or it could be about anything else.
Uh, I don't. I don't know.
While you guys are thinking, I'm going to pull up a really cool picture of the solar system so we can see it. I'll share my screen with you so you can see this. Probably not what you were expecting, huh? So this
Wow.
is the only ever picture that we have of the entire solar system. It's called the solar system portrait because the planets are so far apart. It's really hard to get a picture of all of them together. And so this picture was taken by the Voyager spacecraft as it was leaving the solar system. I think like 10 or 15 years ago. I can't remember exactly. But all these little dots are what it saw of the planets when it turned around and took a picture of the planets just before it left the solar system. You can see how tiny they looked with the camera that took these pictures. They were just barely visible. Neptune, Uranus, Saturn. Jupiter is really close to the sun right there. Earth and Venus are right in the middle of the solar system near the sun. And then that's what the individual little planets look like, just tiny little specks on the camera of this instrument. But it's the only picture we have of the entire solar system. I think it's kind of cool.
Yeah. I don't see Mars on it.
Yeah, they couldn't get a picture of Mars. It was obscured by the sun. Yeah.
Oh.
But yeah, it'd be right in here somewhere, really close into the sun. I guess it was just hidden by the sun when they tried to get this picture. Yeah, it'd be like right in there. Farther away from the sun than Earth, but not as far away as Jupiter.
Mm-hmm.
And this little picture of Earth right there, I'll see if I can find a bigger version of that. It's a really famous picture called the pale blue dot. Yeah, there it is. So when they first took the picture of Earth, they couldn't find it. They just had these little beams of sunlight coming off the sun. And then finally, someone noticed this tiny little speck in one of the beams of sunlight through the picture. And that little dot right there is Earth. And it has like a little, I guess, a little bluish tint to it. So it's called the pale blue dot. You guys have any space questions? Yeah. You got to unmute yourself though. There you go.
In that first picture, why were there squares?
Oh yeah, the squares just showed you a bigger image of the actual planet. Yeah, so the places where these letters are where the planets would actually be in the images that were taken. And then the square is just kind of like a better resolution image so you can actually see the planet itself.
But what about the other squares, the ones that are black and white?
Oh yeah, so those are all the actual pictures that got taken by the camera. It took a bunch of pictures so it could really show you like the full separation between where all the planets were, to show you the distances between them all. So all those different pictures represent a chunk of space between all of the planets. Yeah, great question. Anybody else have a question?
I do, Sam.
Oh, go for it, Howie.
How small is Earth compared to the other planets? Can you put that in perspective?
Oh, yeah, totally. That's a great question. See if we can get a good picture here. The problem with getting a good picture of this is that the planets are such different sizes. Let's see. Oh, this one's pretty good. Yeah, let's do this one right here. I think that's actually pretty good for size. Okay. Oh, we can find something better. Hang on. It's not as good as I was hoping it would be. Let's try this one. Oh yeah, this is much better. Okay, so it's not showing you the correct distances, but this is really good for sizes. So you could fit about 1,000,000 Earths into the sun. You could fit about 1,000 Earths into Jupiter. Or you could fit about 1,000 Jupiters into the sun. So yeah, so Jupiter is about 1,000 times bigger than Earth, and the sun is about 1,000 times bigger than Jupiter. And the smallest planet, now that Pluto got kicked out, is Mercury. And you could fit, I think it's like 10 or 15 Mercuries into Earth. Maybe more than that. Maybe it's more like 20 Mercuries. Let's find out. How many Mercury fit into the Earth? Into the sun. Oh, 16. Yeah, 16 Mercuries would fit inside the Earth. That sounds about right. So yeah, so here are the 4 rocky planets that we talked about earlier. Mercury, Venus, Earth, and Mars, and then the big gas giant planets. So there's no solid surface on any of those planets. They're just big balls of gas. And Saturn and Jupiter in particular are basically like failed stars. They didn't have quite enough gas to start making their own light to do nuclear fusion in their core. And so instead of being stars, they became planets. But if they were a lot bigger, they would have been just like the sun. They're made of the same stuff as the sun is, mostly hydrogen and helium gas. Neptune and Uranus are a little bit different. They do have hydrogen and helium gas, but there's also a lot of methane and other types of gas as well. The other cool thing about the gas giant planets is that they all have a lot of rocky moons. So each of the gas giant planets is like a little miniature solar system. Jupiter has over 70 moons. Not 17, but 70, more than 70 moons. And you can see the 4 biggest ones right here. You can see that a couple of those moons are actually bigger than our moon. They're really big. The largest one, Ganymede, is actually bigger than the planet Mercury. So some really big moons around Jupiter, and the same thing on Saturn. You can see some of its biggest moons right there. Titan is huge. It's a really big moon.
Titan was found to maybe be able to support life.
Yeah, that's right. So there's a liquid fluid on Saturn. It's not liquid water, but it's liquid methane. So on Earth, methane is a gas because it's so warm on Earth. But it's so cold on Titan that methane is a liquid. And so it flows just like water does. And there are methane rivers and lakes and tides. And it also has a really, really thick atmosphere. And so it's super cold, but with some kind of liquid substance, and with an atmosphere and lots of raw materials, yeah, there could be life there. We don't know what it would look like. It would probably look something very different than what we have on Earth, but yeah, it's certainly possible. And the other couple interesting possibilities are some of the moons of Jupiter. I can bring those up for you. They're called the Galilean moons because Galileo was the first one to see them. Oh, there's a really good picture of him. So yeah, so this moon in particular is called Europa. And as you can see, it's got all these cracks on it. And the cracks are all in this really thick ice layer on Europa. And we think that underneath the ice layer is a huge liquid water ocean, similar to the oceans like under the Arctic Circle or under the ice in Antarctica. So we think there's tons of water in Europa. And down at the bottom of the ocean, there could be deep sea hydrothermal vents, like the deep sea hydrothermal vents or deep sea volcanoes we have on Earth. And there could be tons of life down there. We just don't know yet.
Mr. Sam, one question.
Yeah.
So I've been wondering, like, in our space and all the planets that we have, like all the planets and everything, is there like probably like another space with different planets, like we have like our own space, but I was wondering if there's like another one.
Totally. Let me see if I can find this picture for you real quick here. So all the planets that go around other stars are called exosolar planets. Exo is outside, so they're planets outside our solar system. And oh yeah, here's a really good picture. So these aren't real pictures of the planets. They're just artists' ideas of what they look like. But so far, we know of about 4,000 other planets that orbit other stars. So over, I think it's like 3,500 different planetary systems. And these are the ones that are most like Earth. So there are like 16 of them here. So these 16 planets are the most similar planets that we've discovered to Earth. They're all really, really far away. The closest ones are like 10 light years away. And each light year is 6 trillion miles. So still close in the long scheme of things, but they're pretty far away. And so these planets are rocky planets like Earth. You can see they kind of range in size compared to Earth down here. But we think that at least these 6 up top probably have liquid water, and they might have atmospheres as well. Yeah, Alex, you have a question?
Like, are these like in our solar systems, or are those solar systems in our galaxy?
Great question. Yeah, they're all in our galaxy. We don't have telescopes that are strong enough to see planets in other galaxies. So we're just looking at stars in our galaxy. Let me see if I can find a picture that shows where all these stars are. The stars have planets in our galaxy. So we can find a nice map here.
What class is this?
Oh, here we go. Let's see here. Oh yeah, that's it. Okay, so here's a picture of the Milky Way galaxy. And all the little dots show where we've discovered planets around other stars. And so this area right here is where most of all the planets are. They don't actually show all the dots because there's so many of them. So most of them are really, really close to where our solar system is compared to the entire Milky Way galaxy. And you can see where there are some planets a little bit farther away, but all like pretty close to us compared to the entire Milky Way. Yeah, go ahead, Alex.
That one right in the middle, isn't that like really close to a black hole?
It is. Yeah, and it might be a planet. It's probably more likely like a white dwarf. Or excuse me, not a white dwarf, but a brown dwarf. Kind of like an object that's like halfway in between a star and a planet. But yeah, right in the center there's a supermassive black hole that has the mass of about 4 million suns. You can't see the black hole, but the reason it looks so bright in there is because of all the stars and all the other stuff that's getting broken apart by the black hole and spiraling into it. Great question.
Yeah.
See if I can find a picture of a black hole for you since we're headed in that direction. You guys probably know that astronomers actually have just started taking the first real pictures of black holes. And that one that just popped up there, that's the first ever picture right there. So what you're seeing here, all the bright color, all the orange and the white and the red, is all the stuff that's getting heated up as it spirals into the black hole. And then you actually can't even see the true middle of the black hole itself. What we're seeing right here, this black donut shape, is what's called the Schwarzschild radius. It's a little bit larger than the black hole itself. Technically, it's about 2¼ Schwarzschild radiuses around the black hole. So the real part of the black hole is right in the center. We can't actually see it. But this is the best picture we have of a black hole. And I believe this is in a galaxy called Messier Object 87. I think that's where we got the very first picture. And astronomers are using the same telescope right now to take a picture of the black hole in the center of our galaxy. And it'll look probably pretty similar to this. But we don't totally know yet. Let me show you what we think a black hole would look like if we could get really close to it. I think I saw, actually, here's a really good example. So this is from the movie Interstellar, and it's actually probably pretty good. If we could get close to a black hole, this is probably what we would see. And so this long line is what you were seeing in that last image, all the stuff that's heating up around the black hole, as well as this part right here. And the stuff that's just like spiraling around the black hole. And then this area here is what we call the event horizon, or pretty close to the event horizon. It's the area that if you pass through, you can never escape. You're in the black hole forever. Then I can find another good picture of that. There were a couple good ones that I saw. Oh yeah, there we go. So this is another like computer generated image of what a black hole would look like. And this is, again, is like, this is all the stuff that's spiraling in around the black hole. Spirals down below it, up above it, and all the way behind it. So this is like stars and gas that have been ripped apart that are then going to fall into the black hole. Any other questions about black holes or anything else?
So, Mr. Sam, if
Yeah.
a hole swallows us, are we gonna die?
If a black hole swallows you? Yeah, what happens is called spaghettification. Let me see if I can find a good picture of this. Spaghettification. There we go. So the deal is as you start falling into a black hole, the part of you that is falling in first gets stretched out. And so like the bottom half of you, they get stretched out. and eventually you'd get stretched out into a long string of spaghetti before you got ripped apart by the black hole.
Yeesh.
Yeah, probably would not be a good way to die. I would definitely not want to be spaghettified. Oh, there's a good picture.
So, wait, so if we get swallowed up, like, we get stretched out, but don't we, like, probably, like, pop out or our skin starts ripping?
So in the movie Interstellar, he came out of the black hole. But one of the things we know pretty well in astronomy is that it's impossible to come out of a black hole. So you get stretched out as you fall in, and then eventually you'd get ripped apart. And all the little itty bitty pieces of you would travel down into the center of a black hole, which is called the singularity. So I can find a picture for you of the singularity of a black hole. Let's see. That one's kind of a cool picture. This one kind of shows a bit more detail though. Yeah, so we think that as you get sucked down into a black hole, you just start getting, you get ripped apart, but then you get compressed into a smaller and smaller and smaller area until it's like an area smaller than an atom in the very center of a black hole. Really, really tiny area. Yeah, go ahead, Alex.
Last time we were with you, you said that some astronomers believe that after things go into a black hole, they go out a white hole.
Yeah, so that's what some astronomers think, but we don't really know. I'll show you a picture of that though. There are some astronomers think that black holes might be connected to white holes through wormholes. See if we can find a good picture of that. Now, they're totally hypothetical. We've never actually seen one of these things. But what it would be like is a bridge between two different parts of space. So this is like one part of space up here, which you could fall into. You travel through the wormhole, which would kind of look like a black hole, but you come out this other side of space. See if there's a better picture here. That one's kind of interesting. You can kind of see how you could like travel a vast distance in space just through this tiny little wormhole. But we don't really know if they exist or not. Some people think they do. Other people think they might not. We just don't know yet. But yeah, it's certainly possible that you might be able to fall into a black hole and then come out a wormhole, or sorry, come out a white hole going through a wormhole. Yeah, and it could even possibly be time travel. You might actually come out at a totally different time, not just in a totally different location, but a totally different time in the universe as well. But again, we don't really know yet. Great question, though. What other questions do you guys have? Yeah, go for it, Thea.
Wouldn't there be like no singularity if they are connected with the white holes?
You are correct. Nice observation. Yeah, there are some scientists who think that singularities might not even exist. In the mathematics that we have to describe black holes, there are singularities. That's what part of the math shows us about what black holes should have in their centers. But yeah, the new generation of physicists think that singularities might be impossible, that in the center of all black holes. It might get really small, but not all the way down to a singularity. And there definitely wouldn't be one at all if there was a connecting wormhole bridge between a black hole and a white hole. Good observation. Yeah, Alex?
To go on with Thea's question, like I was thinking maybe like there would be like a singularity and then like a white hole, but like I don't think that would really work. And right here it says if the white hole existed, the tunnel would need to be made with a negative mass.
Yep. Yeah, so that's why we haven't seen white holes before, or wormholes. To actually get them to exist, we would need this stuff called antimatter, which is matter like you and me, but instead of having positive mass, it has negative mass. So if you think about like what mass does, mass is the stuff that creates gravity. And Earth has a whole lot of mass. So it has a really strong gravitational force. So it holds us onto the Earth. And so black holes have a huge amount of mass. And so they have huge gravity. So to be able to overcome the gravity of a black hole, you would need anti-gravity, or stuff that has negative mass. And so that's what white holes and wormholes would have to be made of. And we've just never seen that stuff before. It doesn't mean that it doesn't exist. We just haven't found it yet. But yeah, that's what you would need. Yeah, and then like the wormhole would start where the singularity would have been in the black hole.
When you get to decide.
Yeah, go for it, Thea.
Doesn't space have like no gravity? So isn't that negative?
Ah, yeah. So space, you're correct. Space doesn't have gravity. But what Albert Einstein figured out is that gravity is the warping or curvature of space. Let me see if I can find a good picture to show you this. This is pretty crazy stuff. But this is the best idea that we have of what gravity is. It's just the curvature of space caused by stuff moving through it. This one's actually pretty good. So you can think of space as this grid, and every star or planet or moon has mass, and it causes the space around it to warp, to bend. And that bending, that warping of space is what we call gravity. That's what we experience as gravity. So you can kind of see it, it almost has like a funnel shape to it. And so if you can imagine like a marble rolling down a funnel, like the marble goes around and around and around the funnel. So that's why planets orbit stars. And that's why moons orbit planets. It's because the warping of space around them. That's what causes orbits to happen in the universe. It's this curvature of space. Now we're seeing it in 3 dimensions here. It actually exists in 4 dimensions, which is like impossible to actually visualize or conceptualize. Like our brains just can't do it. But this warping happens on all sides of every object in space. And that warping is what we call gravity. So it's actually the bending of space around things that have mass. And so with white holes and wormholes, because that mass is negative, it bends in the opposite direction than it would for something like a black hole or anything else that has mass that we know about. And that's why it could create those bridges between different parts of the universe, because it's warping space in the opposite direction that it normally warps with regular mass. Pretty crazy stuff, right? Hi, Katrina.
Hey, sorry we are coming in late. We've had technical problems.
Uh-oh. I'm glad you made it. Guess what we're talking about? Black holes and the curvature of space-time.
Sweet.
Yeah.
Is there video on?
Yeah, we can see you. You guys have some questions there?
They did. What was your question, Benson?
You ask it.
I don't remember what your question. I don't know what your question is.
Has there ever been a rocket shaped like a fish?
Has there ever been a rocket shaped like a fish?
I mean, rocket ships do have fins. I pulled up a picture, which I think I got a better one here. Yeah, I mean, so yeah, if you think those are kind of like fins like a fish, then yeah, that's kind of like a fish. More like a dolphin, maybe.
All right, so what were some of the questions you guys were asking? They had a lot of questions about NASA and how NASA works and
How many organizations are making?
okay, Betsy, you got to come over here. How many organizations are working on making it to the moon? I can't tell if other people are on. This is weird. I've never done this on my phone.
Oh yeah, there are lots of people.
Oh, don't let us know that.
Yeah, so NASA is the organization in the United States that's officially trying to go to the moon, but there are lots of others. There's the European Space Agency. Just gonna bring up the NASA mission so you can see a picture of what this looks like. They've got some pretty cool new spaceships designed. This is a pretty cool diagram. So this is what NASA is planning to get to the moon. So they've got this Orion spacecraft, and part of the Orion spacecraft is always going to stay in orbit around the moon. And then there are going to be these capsules that can connect to the Orion spacecraft, which will then land on the moon and then can go back to the Orion spacecraft and then can get launched back to Earth. And so there always is going to be like this orbiter around the moon. And then like capsules will come to and from the orbiter and then get sent back to Earth. Yeah, the Airbus DS. So that's what NASA is planning. There are lots of other governments, not the US government, the Chinese government, the Indian government, the Israeli government that are also trying to create new lunar landers that will get people up there. And I think NASA is planning to have people living on the moon continuously by the year 2030. So 10 more years. And we'll actually have people living on the moon all the time. Let me see if I can find this little video about how NASA is planning to go to the moon. Let's see if I can find it here. It's called We Are Going. See if I can find the video really quick. It's a really nice, well done video. Let's see. Oh, they say by 2024 right here, even earlier than I thought. Okay, cool. I'm gonna pause this really quick because I think I need to change the volume setting on my screen really quick. I'm gonna stop the share and then reshare to make sure you guys get the right volume here. Give me one
You can
sec.
share your computer sound.
Yeah, that's exactly what I'm gonna do. All right. Okay, now I got that correctly. All right.
The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024. And this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
this system is capable of being the catalyst for deep space missions. We need a capsule that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable.
That can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity.
In a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
Cool stuff, right? Yeah, so that's how NASA's going to do it. I don't exactly know what the other government space agencies are planning, but probably something similar to what NASA's planning. And you guys probably know about SpaceX. They're trying to go directly to Mars. So it's a totally different type of mission. See here. Where are they at? Want to hear about what SpaceX is planning? All right.
I think most likely the form of government on Mars would be somewhat of a direct democracy where you vote on issues, where people vote directly on issues instead of going through representative government. When the United States was formed,
He's not talking about going to Mars. He's talking about like what the government's going to be like. Let's see if we can find something directly about.
If you're done talking about that, I thought I had another question.
Oh yeah, what's your other question?
What is the percentage of water and oxygen, carbon dioxide on Venus?
Carbon dioxide is way higher. I don't know what the exact percentage would be. Let's look it up. proportion of carbon dioxide to water on Venus. Let's see here. 96.5% carbon dioxide. And the remaining is 3.5% nitrogen. So water is almost non-existent. More carbon dioxide than anything else by far. Yeah, there may be no water vapor in the atmosphere except very, very high up in the atmosphere of Venus. Basically, what happened on Venus is a runaway greenhouse effect. The amount of carbon dioxide kept on building up and building up and building up and trapping more and more heat. So more carbon dioxide, more heat, more carbon dioxide, more heat, so on and so on, so that the atmosphere on Venus is so thick and the temperature is so high that you could melt lead on the surface of Venus. It's about 900 degrees on the surface of Venus, so pretty toasty. And you can see here the pressure on Venus. It would feel like you were 900 meters underwater. That's how much pressure you would feel just standing on the surface of Venus. So it'd be pretty uncomfortable. That's why the spacecraft that we've landed there only lasted for a few minutes before it stopped working. The temperature and the pressure just totally crushed it. Great question, though. I didn't know it was 96.5%, but now I do. Oh, you're muted. I can't hear you.
I think he had just made some plans for, I don't know, colonizing Venus that he's going to have to rework now.
Oh, no, but it's possible. So there are actually scientists who are thinking that life might actually exist in the upper atmosphere of Venus. Check this out. What is the name of that platform? Platform planned for the upper atmosphere of Venus. It's pretty cool, actually. Can't remember the name of it. Oh yeah, there it is. This thing is so cool. But I wanted to find the name of it. Let's see, let's go to the website first so we can find the name of it. All right, it's called VAMP, the Venus Atmospheric Maneuverable Platform. So because the atmosphere is so thick, you could basically have like a glider that would just sit stationary if you just had a little propeller. So it works both as like a glider and as a platform that you could maneuver around. And there's actually some evidence that the upper atmosphere of Venus might not be that different from the upper atmosphere of Earth. There might actually be water vapor up there. There's definitely carbon dioxide, we know that. And the temperature is actually fine and the pressure is fine as well for life. So there could actually be life in the upper atmosphere of Venus. And if there is, this platform will find it. It's being designed right now. I don't even know if there's a date set for when it's actually going to be launched. See if they say anything about it there. Doesn't look like it. I don't think it has a launch date yet. But eventually, this thing is going to be flying through the upper atmosphere of Venus. And yeah, maybe it will find life. We don't know. So yeah, colonization might be possible if you have platforms like this. Yeah, Thea, go ahead.
What happens if two neutron stars collide?
Oh, you get lots of gold. This is like the coolest thing that astronomers discovered just a couple of years ago. Yeah, it turns out that most of the gold in the universe comes when neutron stars collide. And you also get gravity waves. So this was actually really cool. Ooh, here's a, oh, I like this video. Yeah, maybe we'll just watch this video. Let's see who made this video. If it's a good source like NASA or something, Maybe we'll watch it. I want to make sure it's actually legit, though. Let's see. Oh, the Massachusetts Institute of Technology, MIT. These guys know what they're talking about. Let's watch this. Sorry, I didn't get to the full screen there until too late. Let's bring that back so you can see that again full screen, because that was pretty cool. You see the gravity waves up there. I just wanted to pause it there because this is actually a digital image similar to what we actually saw. So the discovery of gold being created from neutron stars happened a couple years ago because astronomers not only saw X-rays coming out of a collision like this, but they also got gravity waves. And they learned a huge amount about the explosion. And so this is like a visual image of what it would have looked like if we could actually see this type of radiation. It's way too powerful for our eyes to see. It's in the X-ray part of the spectrum. But this is probably similar to what it actually looked like when two neutrons. And then probably a good chunk of this stuff that's being produced is gold. And all the other elements on the periodic table as well, everything that exists in the universe. But yeah, from the leftovers of the explosion, you get tons and tons of gold. And that big plume that we just there is, we saw is called a bow shock. And we actually saw that as well. It's this big jet of material, of super hot radiation that gets ejected from the explosion. Great question. That was fun. So yeah, so they explode and you get gold and lots of other stuff. And then they also produce these gravity waves, which are like ripples in space-time. Remember that picture we saw earlier, like with like those three balls on that grid pattern. So it basically sends like little ripples through that grid pattern, just like if you dropped a rock into a pond. Yeah, go for it, Thea.
Could the Big Bang have been two neutron stars colliding, or was it something different?
It was something different. It was way more energetic than just two neutron stars. The most energetic explosions we've ever seen so far are actually more energetic than neutron stars. They're actually called quasars. Explosion. It was actually just happened a couple weeks ago, I think. Most powerful quasar discovered, YouTube. See if this is a good one here. Oh yeah, video from space. Looks like there's an ad coming here. There we go.
Quasars are the most luminous objects in the universe. Now, astronomers using the European Southern Observatory have found a quasar that's more than 5 times more powerful than any previously seen. Astronomers on Earth first became aware that quasars existed in the 1950s. Back then, the term quasar meant quasi-stellar radio source because they looked like very bright points on the sky at radio frequencies. Now, we've come to understand that they are actually gargantuan sprays of matter and energy powered by supermassive black holes in the centers of young galaxies. Wait, I hear you say, don't black holes suck matter in? Well, sure they do, but as they do, they tend to shred that matter apart, spinning it up, forcing it outward at very high speeds. Researchers have cataloged more than 200,000 of these objects. The very nearest one is more than 600 million light years away from Earth, and most are at least 3 billion light years back in spacetime. But this discovery is the first to confirm the theorists' predictions that these cosmic blowtorches could truly be this hot and this bright. For Space.com, I'm Dave Brody.
Space.com. So even those quasars are not even close to producing the energy that came out of the Big Bang. The Big Bang was something totally different entirely. And to be honest, we don't really know what it was. But we think that it gave birth to this universe. And it might not be the only time that's ever happened. There might be an infinite number of universes out there. We just don't really know. But what the Big Bang was, nobody really knows for sure. But way more powerful than neutron stars or black holes or quasars. Great question, though. So we just have a couple more minutes. Does anybody else have any last questions before we head back to our own homes? No more questions, huh? All right, maybe we'll end with the trivia question then. I'll stop sharing my screen so it's easier to pull up the chat. All right, let's see. It's a good trivia question. Do some more, I'll do another planet trivia question. Ooh, here's a good one. Which is the hottest planet in the solar system? If you think you know the answer, you can write it in. Oh.
I'm just so, I don't want to.
We got one answer. A couple people are answering in the chat window. Anybody else want to venture a guess? You can type it in the chat window. Got a few answers in there. So all great guesses in the chat window about Mercury, because it is the closest planet to the sun. But because Venus has such a thick atmosphere, it actually is hotter than Mercury is. So our correct answer was given there at the very beginning of that question. Nice work. So yeah, so Venus is the hottest planet. The sun is definitely hotter than planets are, but the sun's a star. But yeah, the sun is like thousands of times hotter, actually over 1 million times hotter than the hottest planet. So yeah, stars are pretty toasty compared to planets. Well, it's 5 o'clock, everybody. Thanks so much for joining me for Ask Dr. Sam. I hope you had fun. I definitely did. And hope to see you next week.
Thank you.
Yeah, you are very welcome. Have a great evening and a great week. We'll see you later.
Bye.
Bye. Thanks, Howie.
See ya.
Talk to you later, man.
All right, sounds good.
Bye.